Did I start recording? Yes, I did. Well, let's see. All right, what'd you end up with?
I had 8y to the 17th over negative 27, x to the 16th, z to the 5th.
All right, hold on. 8y to the 17th over negative 27.
X to the 16th, z to the 5th.
Z to the 5th. All right, so, Dakota, what do you think about that answer?
It's not what I got.
It's not what you got. Well, it's the right answer.
Really?
Really? So you shocked yourself. So that is correct. All right.
Well,
So take a look at what you got, and let's see. Lizzie, did you get that?
no.
It didn't look like it. From your reading the room, I used it like, no. All right, let's take a look. What I would do with this one is I'd take this negative, since it's a negative 3 on the outside of a group, I'd move it down below. And so now I can take care of this here because it's not going to be affected by anything. So to save a little bit of steps, I can square that, which would give me on top 16. Is that me again? Shoot. Not convenient. Did you do that? Good. She is. Sure. Hold on. Jordan, you've been requested to be on the phone here.
Right.
Y to the 10th?
Oh, there's not.
Yeah, I said it every day. Yeah.
Someone move that down, make it to the third power. Since you already have that expression down there, I'm going to put it in parentheses because you're going to have to multiply those two together. I'm going to cube it first, though. So 16 x to the negative 4, y to the 10th. Okay. So then, all right, cube it on that right-hand side, or that expression there. 27, x to the 9th, y to the negative 3rd, z cubed. Okay, for that one. All right, what do we got, or what are you going to do from there? Okay, because, I mean, you do these problems, there's a lot of different things. Brandon, what can we do?
You could, like, combine, like, terms, or, like, multiply the two things on the bottom.
Yep, I would multiply these two things. Some people might start moving all the negatives and making positive. You can do that. I think I would do like Brandon said, multiply those two together. And so I got 16x to the negative 4th, y to the 10th, all over negative 2 times 27 is negative 54, x to the 12th, y to the negative 7th. Remember, you're just adding exponents. And then z to the 5th. Z to the 5th. 16 over 54. Now, the whole thing is going to be negative. So the only thing I wouldn't do is I would just make it, you can make the negative with the 8. It doesn't have to be the 27. It doesn't matter. Just the whole thing needs to be negative. You could have actually probably divided 16 by negative 2 and gotten 8 there. It doesn't matter how you get there, but it's going to be 8 over 27 when you reduce. And so I'm going to make it negative 8 over 27. And then negative 4 minus 12 is negative 16. That'll go down below. 10 minus negative 7, y to the 17th, z to the 5th. So there it is. All right, so there's a lot going on in that problem. I mean, probably you got basically every exponent rule we can come across in one problem. All right, homework-wise, let's see. All right, 26. There's your answers of 26 and 28. 0 and 1/2 for 26. 58. What page is that? 164. for that one. Now you got to make sure all those absolute value inequalities they get written in interval notation. For your final answer for tomorrow. Tomorrow's test, it's like 12 or 13 problems. Okay, and so it's 100 points, so about 8 to 10 points each. So like the little things, like if you don't write things correctly, if you don't put the union in there, I take off like a point. Like I'm not gonna take off like 6 points, but I'll take off a little bit here. So you got a lot of follow the little details, okay, on here. I'll stress again, finish the test, go back and check. Don't start checking number 2 and something goes wrong and you spend 28 minutes and you forgot to write a negative down. Okay, and then you got 6 to go at the end of the period. You don't get done, what you don't get done gets counted wrong. That's how it works. Okay, you got to get through it. Honestly, if you're prepared, that won't be an issue. Okay, you know what you're doing, you're prepared, you'll get done with time to check.
Can you go over to number 27?
Yep, 27. What's the original problem look like?
It's 2, then absolute value of 3x minus 4, then plus 9 equals 7.
All right, subtract 9.
-2.
And so we get 2 times the absolute value of 3x minus 4 equals -2. And then when I divide by 2, you get 3x, absolute value of 3x minus 4 equals -1. For any of these, once you get to this point, whether it's an inequality equation, it equals a negative, yeah, stop. Okay, you just got to stop and look at it, all right, and just think, does this make sense? Can ever equal negative? Because you just split it apart and you'll get 2 answers. Okay, what did you get for your answers?
I got 1 and -4/3.
So let's just, if you throw in 1, here's what happens. You get 3 minus 4 is -1, right? Absolute value of that is 1. That gives you 2 plus 9, which is 11. So it won't work. So you'll get the answer, but if you go back and check it, you won't. So once it says a negative, boom, done. No solution. Okay, for that one. Also for make sure you're doing 51, 55, 57, those correctly. Most people were. We're going to keep submitting it online. It's a little bit more of a pain for me, but I like it because I can at least look at everybody's paper and I can spend a little bit of time and just say, if you made a mistake, I get an idea where you made it. And then it's a little more information for me because when I go by and check it, I don't really get the full picture. I just see whether you finished it. So unless otherwise noted, we're going to keep submitting for that. So 58, what's the original problem there? Katie, you got that handy?
I think I'm gonna.
Did you write it down?
I wrote down the problem. I think I skipped a step while I was writing it down though. So,
Never mind. Who's got it? Andrew, you got it?
The absolute value of 3x minus 3
Okay.
is greater than or equal to 15.
Okay, so for greater than or equal to, make sure when you do the second part for these, it's always going to flip the sign and be negative. Okay, so you got to do 3x minus 3 is less than or equal to -15. And this is and then 3x minus 3 is greater than or equal to 15. Some people forget to flip that sign. Like I said, for this class, for the most part, what I looked at was good, but I wanted to hit that again. If it's a less than or equal to, 3x minus 3 is less than or equal to 15. You can do it as 2 equations, or you can just sandwich it in between -15 and 15, either way. Okay, I prefer that way, but I'm not going to require one or the other. Anything else on the homework? Okay, I'm going to go over a few more problems that tend to be issues. I'm going to give you time to work on that review sheet, that review problems. There's no practice tests. Okay, that's problem for problem like the tests. Okay, you're going to have to know these things. Now I said there's going to be 3-word problems. I lied. There's only going to be 2. Okay, I just looked at everything and it just was going to be a little bit too much. So there's going to be it's going to be 2 of the 3. I'm not going to tell you which 2. It's either going to be a mixture, distance, rate, and time, or one of the investment problems. Okay, so 2 of those 3 will be on the test. Got it? Let's go over a couple other things here. Just from, whoa, what's that? Oh, it looks like a mixture problem. All right, let's do that one. Shocking. I haven't seen any of those before. All right, I'll go through it with you, read through it. If you're confident in setting up the equation, set it up. I'll give you a second here to digest the information. Oh, you already can. Did they bring you a little wheelie thing? No. I've seen those before. Okay, keep doing that, Justin, and see if you get. Let me know what answer you get. Okay. All right, Marshall, you think you know what you're doing?
Not really.
Not really. Good thing the test is not until a week away. Whew, you got plenty of time. All right. So remember, you think you're going to have your. We're going to take our 60%, and we're going to add our 80% to that, and we're going to end up with 75%. Now, if you want to do the chart, that's great. Go ahead and do that. It helps you. I'm just going to go through here. How much of the 60% do we have? Do we know the amount? 60 grams. So you want them all. So we want to find out how much pure gold we got in each one. So that's 0.6 times 60. How much do we have of the 80%? Do we know? No. So we let that be what? X. So you get 0.8 times X. The last one is going to be 0.75. What's the amount? X plus 60 is going to be, you've got to add those two together. And so make sure it's parentheses X plus 60. Now, if you get that, you should be good. Now we can solve it. 0.6 times 60 is 36 plus 0.8X equals 0.75X plus, what is that, 45? Subtract 0.75, subtract 0.75. And I get 36 plus 0.05x equals 45. Subtract 36. And I get 0.05x equals 9. Divide. And then I get x equals 180 grams. Okay. Justin, you get the same thing? No?
Nope.
What'd you get?
I got 80. 80 grams.
You got 80? Because you let this one be X, right?
Yeah.
And so you said that one was 60 minus 6. Yeah, no, that's not going to work. I was just trying to think. So X. It would be X minus 60. Yeah, it would be that. All right, 180 grams. Good there? All right, so that is a mixture problem. All right. If you haven't realized it yet, you're probably going to see something like that tomorrow. Okay? Solve the following by completing the square. I just want to hit these together because these are, like I said, ones that I find people miss more often than others. All right, you got to follow directions. You can't just throw quadratic formula on this one and say, oh, there's your answer. You have to use completing the square. Okay. Adam, you remember?
I don't.
You don't? Good thing we got a week till the test. Okay. Good thing. All right. Couple key things. Completing the square. This is the one where we want to move the constant over. So we want to make this 4y squared plus 12y equals positive 5. What do we have to do now? Okay.
Divide by 4 to get rid of the coefficient.
You got to get rid of that coefficient from the y squared. You cannot complete the square using with a coefficient in front. So I divide everything by 4, and that gives us y squared plus 3y equals 5/4. To keep it as no decimals. Absolutely not. No decimals in completing the square. We're going to have to add something to both sides. Marissa, you remember how to find that something? And then square. Yes. Yep. Divide to 3.5. Don't make it a decimal. Don't make it 1.5. So just make it. So take 3. I multiply it by half. It gives you 3 halves. I'm going to circle that because we're going to come back to that later. Square. 3 halves squared equals 9/4. That is what goes into each side. Okay, 9/4. The left side is going to factor into a quantity squared. Something times itself. Do you know what that will be? Matt?
Parentheses y plus 3 over 2.
It is.
I don't know why I blanked there.
Yeah, so this is where the 3 halves comes back into play. Whatever, when you divide that number in half, that is going to be what's in parentheses. 3 halves times 3 halves is 9/4. When you add them together, you get 3. Quantity squared. Now this works out nice. 5/4 plus 9/4. That gives you 14/4. All right. To me, that's the hardest part. Now what do? We take the square root both sides. Okay. So I got the square root y plus 3 halves quantity squared equals plus or minus 14/4. So you just get y plus 3 halves equals. Now treat this as 2 separate problems. Like take the square root of the top and take the square root of the bottom. Well, we don't know the square root of 14. But we do know the square root of 4, which is 2. So your denominator is going to be a 2. And more often than not, these 2 denominators are going to be the same. Okay. Now just move your 3 halves over, subtract it, and I get y equals negative 3 halves plus or minus square root of 14 over 2. Okay? And there's your completing square. Make sure that coefficient is a 1. Got to be a 1. Okay. All right, so that's completing the square. We did a mixture problem. Let's take a look at a radical problem. Square root of 7x plus 1 minus square root of 5x plus 4 equals. Oh, yeah. It's the length one.
Is there gonna be a video of you doing all this? Or
Today?
yeah.
Yeah, I'm recording right now.
Oh, sweet.
So, yeah. Forgot to do it first period. So I'll put it on there. Yeah, every day should be a video. Tony.
For the one we just did, can you combine the denominator and just make it 1?
Yeah.
Okay.
So I think this is what he's saying. Can you, and I'm fine with this answer, but he's saying, all right, we both have the same denominators. Can I just make this negative 3 plus or minus square root of 14 over 2? Yeah, that's fine. Okay. No big deal. All right. Jordan, welcome back. Remember what to do here? No. Good thing we got time. Good thing we got some time. All right. Aiden does.
You add the radical 5x plus 4 on this.
I would do that. You need to isolate one of the radicals. Okay, one of the radicals first. Don't try to square it yet. And I Anytime I'm dealing with something, I'm trying to eliminate as many negatives as I can. So I would move the 5x plus 4 as opposed to the 7x plus 1. Add it. So we get square root of 7x plus 1 equals 1 plus square root of 5x plus 4. All right, Justin, what do you think?
Square everything.
You gotta watch how you say that. You may be right, you may be wrong. We do have to square, but you need to say square both sides because you can't just square the individual pieces. Okay, so if you meant square both sides, you're right. Which means when I square both sides, that becomes 7x plus 1 squared, but you have to put the right-hand side in parentheses, squared, which means we're actually going to do what to that side? We're actually going to FOIL it. Okay. If you just square the individual pieces, that's not mathematically correct. You do get 7x plus 1. I'll go ahead and write this out. Okay, so you get that. So I'm going to FOIL 7x plus 1. There's nothing I can do with it at this point. I got to do a little bit more work over here. So 1 times 1 is 1, plus square root of 5x plus 4, plus another square root of 5x plus 4, and then you get 5x plus 4 when you multiply the two radicals together. All right, on that right-hand side, I'm going to group my like terms together. Left-hand side is still 7x plus 1 equals 5x plus 5 plus 2 radical 5x plus 4. All right, I'm going to stop and make sure you caught up. Okay, again, isolate the square root. Okay, we're going to have to get rid of the radical. Isolate the square root. I'm going to subtract 5x. I'm going to subtract 5. And that gives me 2x minus 4 equals 2 times square root of 5x plus 4. Now, when we came to this stage, when we're doing our homework problems or the previous problem in class, this 2, we said you got two options. You can square both sides right now, or we can divide by 2. I said I would only divide by 2 if it went into the other side evenly. Well, will it go into 2x minus 4 evenly?
Mhm.
Yeah, so I'm going to divide by 2. It'll make it just a little bit cleaner. So when I divide by 2, I get x minus 2 equals square root of 5x plus 4. Now square both sides. And you do have to FOIL over here. All right, at that point, you gotta think, all right, what do I do from here? And one little thing happens that might throw you for a loop. That doesn't really make it that much harder. I'm gonna set it equal to 0. I'm gonna set it equal to 0. Minus 5x minus 4. All right, when I do that, what do I get? Okay, matters.
X squared minus 9x equals 0.
Yep, I get x squared minus 9x equals 0. And we're so used to getting that constant, we're like, all right, we're all thrown for a loop here. All right, look at it. I want you to think. What can I do with that?
Take out an x.
All right, good. Factor out a GCF, x. You're used to that constant, and you're used to factoring it into two binomials. Well, I don't have that constant, but it does have an x account. Factor out the x. You get x times x minus 9 equals 0. And now we got x equals 0. We get x equals 9. Now I kind of made a big deal. I said don't check your answers till the very end. But with the exception of this problem, Why do you have to check your answers for this problem?
Because you can't have negatives under a radical.
Can't have negatives under a radical is one thing, and we might get what's called an extraneous solution, which even though all our work is correct, doesn't make the equation true. So you have to check anytime. What makes us have to check is when you square or cube both sides of an equation. Since we did that, you have to check your answers. All right, plug them both in. It doesn't take long for this one. And just evaluate whether they work. You're not checking for math correctness, you're checking for extraneous solutions, a little bit different. And one of these doesn't work. I'll be honest with you, sometimes they both work, sometimes only one works. Okay, so you can't go on that assumption, oh, one won't work. When you check it. Which one doesn't work? What'd you say? Zero doesn't work. Okay, you plug in 0 in the top. And then what do I end up with? If I plug in 0, I get a 1 minus 2, and it says it equals 1. And that doesn't work. So you got to throw 0 out, and you got to be pretty clear for your answers that you are eliminating one of your answers, and the only answer is 9. Okay, the only answer is 9. All right, I wanted to hit some of those. Here is those review problems again. So the end of the period, you need to work on them if you haven't done them. If you have done them, the answers are on Canvas. Okay, all the worked out answers. You check them over so you can go to Canvas